Hi, in today's video, my friends and I will presenting to you about vector in navigation. In this group, we have 4 members. My name is Muhammad Jazir Rushdan, and following me, we have Muhammad Amir Rafizi, Muhammad Fazil, and Muhammad Rifa'i. And in this video, we will presenting to you about vector in navigation. So now, let's see what is vector. Vector is a quantity having direction as well as magnitude, especially as determining the position of one point in space relative to another. There are 10 types of vector in mathematics, which are zero vector, unit vector, position vector, co-initial vector, like and unlike vector, coplanar vector, collinear vector, equal vector, displacement vector, and negative of a vector. What is vector in navigation? In navigation, a state vector is a set of data describing exactly where an object is located in space and how it is moving. For example, let's say A is Johor Bahru, B is Kuala Lumpur, and C is Penang. There are directions and distance connecting these places, which in vector scalar it can be A to B, B to A, B to C, C to B, C to A, and A to C. So now let's watch my friends do the questions about vector.
Okay, let's look at this question. This question about scalar dot product. Given A, I plus 3j minus 4k from house to shop, and B, 2i minus 2j plus k from shop to school. And we need to find the scalar dot product A and B. Then we list out the information given. And to find the scalar dot product, we need to write like this. And the alphabet with the same alphabet, we bring out the numbers and we multiply it, like I positive 1 for A, and for B the I is positive 2, and we do the same for J and K, and we add all of it, and then we get the answer is negative 8.
Now, let's move to the next question. Given the position of Akmal represented by the letter A and Adam represented by letter B at points 4, -10 and -8, 6 separately, find the vectors for AB and magnitude AB. OA equals to 4i minus 10j, OB equals to -8i plus 6j. AO equals to -4i plus 10j. AB equals to -4i plus 10j plus -8i plus 6j equals to -12i plus 16j. Now, let's find magnitude AB. Magnitude AB equals to square root -12 square plus 16 square equals to 20. Now, let's find unit vector. AB over magnitude AB equals to -12i plus 16j over 20 equals to -12i over 20 plus 16j over 20. So the answer is -3 over 5i plus 4 over 5j. Thank you.
Hi, my name is Muhammad Rifa'i bin Limansah, and my metric number is 08 DKM1A 1013. Okay, so let's take a look at this question about vector in navigation. So an aeroplane is traveling a speed of 500 miles per hour heading north 30 degrees west at a fixed altitude. The airplane encounters a wind blowing with velocity of 70 miles per hour in the direction of north 45 degrees east. What are the resultant speed and the direction of the airplane? So first of all, let's illustrate the information that we got from the question for better understanding. So this is the airplane and this is the wind. So let's calculate the resultant speed. So to get the resultant speed, we must add the vector of the airplane speed and the vector of the wind speed. Okay, so let's calculate both of them. So if you notice here, I use 120 degree instead of 30 degree because I use real angle just like we do in trigonometry. And I do the same for the wind. I use 45 degree. Okay, so let's continue. And then we got the answer, which is negative 200.5 and 482.51 for the horizontal and vertical component of the resultant speed. And now we can calculate the resultant speed using the formula to calculate the magnitude of a vector. And then we got the answer, which is 522.5. Okay, so let's move on. Okay, now that we have the vertical and horizontal component for the resultant speed, for the vector of the resultant speed, we can illustrate them using this diagram. And so now we need to calculate the direction of the airplane. So to calculate the direction, we use the inverse of tangent times 482.5 divided by 200.5, and then we got 67.4 degree. But that's just the reference angle, so we need to subtract 67.4 degree from 90 degree, and then we got 22.6 degree. So the resultant speed of the airplane is 522.5 miles per hour, and it's heading north 22.6 degree west. So that's our answer for this question.
Therefore, in this video we have learned about what is a vector. Second, we know how to apply scalar dot product of two vectors, and lastly, we know how to apply vector cross product of two vectors. After all, that's all from us. Thank you so much for watching.